this. All right, so welcome to week 3. I know you've been sitting here for a while because we just went over last week's homework, but today we're going to be taking what you learned from last week, kind of applying it to some new scenarios, while also learning some extra stuff that I think is kind of important. So that's assemblies. So we're kind of just going to hop right into it. We're going to do assignment 7, which is reverse engineering the engineering fountain. In many CAD softwares, they do have a function where you can import, photos and other things into your sketches, or just your workspace in general. And this can be really useful when you're designing around things that already exist, right? In this case, we're using the engineering fountain, taking this photo from like a side shot, and then we're going to create our own version of it. But it can be really useful when, you might want to make a container for something of a slightly irregular shape or something like that. You can take a nice photo of it, maybe put some reference down, like a lot of people put maybe a coin or something of a known dimension in the photo, and then they can use that reference to kind of scale things properly. In this case, we're not really going to be dealing with scale because, we're just going to be eyeballing this, but it is a pretty useful function in CAD softwares. So for this, you should be downloading this nice photo of the engineering fountain. We're going to use that as a base. I'm going to create new design here. And then instead of creating a sketch, we're going to be inserting a canvas. So if you go to Insert and Canvas, again, it shows a nice photo preview. One of the things that I didn't really mention earlier is that people like to do this when modeling cars and stuff, because they'll draw like a nice organic shape, and then they'll take a photo and then import it, and then they'll do like a front shot, like a side shot, like top view and everything, and then they'll kind of mash a bunch of canvases together, and then they'll create like 3D sketches that follow every single view to kind of create that car. I think one of my friends modeled like an Audi R8 like that. They have a bunch of photos at different angles, and then they can kind of reverse engineer the shape of the car, which is pretty cool. So for the canvas, you're going to find it in your file explorer. You're going to need to pick a plane. It doesn't really matter in this case, but I think picking either the front plane or the right plane is probably best. So when I click on it, it places it, and then you can see a bunch of different parameters here. You can change the scale factor and stuff like that if you're interested. I don't know why this is like compressed. That's weird. Anyways, you can scale it up or down. I think I'm just gonna kind of leave it how it is. But you can also change the opacity. So if you want it to be a little bit more see-through so you can see your sketches and stuff, you can do that. I'm just gonna leave mine at 50, which is the default, but if you want to change that, you can. And then I'm just gonna confirm that. I'm also not going to really move this image around. You can kind of see that it's not perfectly centered on, across the origin, but it's not a big deal because we're going to be just creating one of them and duplicating them. So yeah, I know it bothers some people, but I think it's okay. So we have this canvas. I'm going to make a sketch. I'm going to create it on the same plane that we placed the canvas on. And then we're going to just start drawing. So for this one, it's not a big deal if it's not fully constrained, because this is mostly just kind of getting you used to the concept. But again, it's good practice to fully define your sketches, but for this, it's really not that big of a deal. All right, so what I'm going to do is I'm going to trace this engineering fountain. I'm going to start with all the straight lines, and then I'm going to do this curve right here. If you didn't know, I believe that the curve on the engineering fountain is modeled after the e to the x function. So it's not actually a circle. So you can't create this with a circle. So we're going to just use a spline to get close enough. But first, I'm going to start with some straight lines here. Again, it doesn't have to be perfect. This photo isn't exactly, or isn't the straightest photo. So you'll see that my fountain doesn't quite line up, but it's okay. So I made that. I'm gonna get this, somewhat close. And then, similar to the wire last week, we're gonna be using the fit point spline. So I'm gonna start at the top, click my way down. One thing to note for this this assignment specifically, I found it to be the easiest if I create points at the end of these fountains, like spire pieces, because I personally like to make a really big sketch and then trim it away. So I have this, and I'm gonna confirm it. And then if I hide the canvas with the eyeball, you can kind of see what's going on here. We have that curve, it's all one piece, but now I'm going to separate it. So I'm going to draw two vertical lines, one at each point that I created on the ends. Looks good to me. And then I'm going to trim away the excess. So I'm going to hide the canvas so you can kind of see what's going on. But I'm going to trim away at here and here. You'll notice that there's a bunch of these like green arcs and stuff going around. That's not really a concern because that just kind of represents how the spline is created. So, you can manipulate these lines and stuff like that, but we're not really doing that because it already is the way we want it to be. But yeah, if you're worried about those green lines, then that's why. Okay, who's... it's insert canvas. Is anyone... What's up? Oh, it's a W. Or I have to convert it so I can change it. You might need to like hear it online. Yeah. I just look up like or I would read down it. I think I do. It was on the desk. If this is your mouse. Okay, Who needs more time on this? All right. So now that we have this sketch, it's fine that it's not fully defined in this case. But I'm going to extrude it now. I'm purposely going to extrude it incorrectly just so you can see how the way you extrude something might affect your final geometry. So I'm going to extrude it. I'm going to select these two closed bodies here. And then you should set your extent type to be symmetric because you want to extrude it to be symmetrical across the plane that we created it. I'm going to do it as one side so you can see what happens when you do it incorrectly. It's incorrect for this assignment, but you know, depending on what you're going after when you're designing stuff, this may be good or bad. So I'm going to extrude it in this direction. So yeah, we have this here. What we want to do, obviously, is to create 4 sets of them. So similar to, you know, adding patterns and sketches, you can also pattern solid bodies and features. So we're going to create a circular pattern here. I'm going to select the 2 bodies that we have. And then when it asks us for the axis, I'm going to click that. In my case, it's that green one off the origin. And we want 4 of them. So you can see here, this isn't exactly what we're going for, right? We want all of them to kind of be centered along that circle, but they're kind of at this weird offset. So I'm going to confirm this. But you can see it's because of how we extruded it, right? So I don't know if you can see the line very well on the projector, but there's a red line that goes across like the middle of my screen, and that's kind of showing me where that plane is, right? In this case, it's like the front plane off the origin. And this isn't a symmetrical extrusion, so it just only went to one side. So in this case, you know, it's not what we want. We want it to be nice and symmetrical. So I can go back and change this. So if I go back in the timeline and edit the feature, if I change this to symmetric and I divide the initial value by 2, you can see on that red line, there's a nice even extrusion going out from both sides. And when I confirm it, it looks a lot more like what we were going after. If that makes sense. Does that make sense? Yes. Again, this is like it's a little thing that I'm talking about, but whenever you are modeling stuff and you're like in a rush and you're wondering why your extrusions and patterns are looking weird, this might be something you want to check. So, yeah. Okay. So we did this. We did that circular pattern. Now we want to add a little bit more detail to this. So what I'm going to do is I'm going to add the detail to one of these models, and then I'm going to copy it. What you could do is you could, you know, create that feature here and then pattern it again and then mirror it and pattern it again, or some combination of the two. But the other thing you can do is you can cleverly use, you know, the timeline and put things in a certain order to do it, to make it do what you want. So what we're going to do is we're going to make it do, create those details and then also pattern it at the same time. So to do that, we're going to want to edit the original one. if you edit any of these three, you're going to create a dependency, right? We were talking about dependencies last week. So you want to make sure you edit the original one. If you want to be sure that you're editing the original one, you can move the timeline back and edit it. But I'm just doing things out of order just to kind of show you that you can move things around. So I'm going to make a sketch on that plane or that face. I'm going to show the engineering fountain, and then I'm going to start tracing some details. Before I start, I'm going to project these faces onto my sketch to kind of bring those lines in. Because I'm basically just going to draw like one spline that goes down here, and then I'm going to trim away. And then using these projected faces, we're going to get like fully closed like bodies just by creating one sketch. And this is nice because if any of these dimensions were to change, because it's projected from these faces, it'll change with it. So I'm going to press P. I'm going to project these two faces. You can see there's these nice pinkish colored lines. And then I'm just going to create a spline. The spline doesn't have to be perfect. Again, it's just kind of a representation or an inspiration. I'm also making sure that I'm clicking these projected lines on both sides, so there'll be closed bodies once I finish. So if I hide this, if I hide the canvas, even the bodies, you can see what I did here, right? I projected these faces and then I drew on it. I drew this detail line, but you can see because we have these endpoints here, it splits the whole original body into 4 different pieces. So we can select these things and manipulate them for extrusions or whatever we want. So I'm going to show this body again. And then I'm going to create an extrusion. So I'm going to extrude these two. For the details, I want them to go inwards. So I'm going to make the arrow going that way. Here we go. Operation set to cut. I'm going to press OK. You can see here we have this detail here. Good. Raise your hand if you need more time. Okay, I will hold up for a second. All right. So now that we're here, Okay, so now that we have this, we kind of want that feature to be symmetrical on that initial detail or the initial body. So what we could do is, we could make another sketch and then project the sketch we just made onto that face. But what we're going to do is we're just going to mirror that feature. So similar to mirroring in sketches, you can mirror things. You can mirror features and stuff like that as well. So I'm going to create a mirror. In this case, I'm not mirroring a body. I'm going to be mirroring a feature. So I'm going to change this. It's going to ask me to select it. In this case, it's that extrude. And then it's going to ask the plane. So because we made the initial extrusion symmetric, we can just use one of the initial planes instead of having to create another one. So I select OK. It should work. So that looks good. Does that make sense? You want me to raise your hand if you want me to do it again? Okay. All right. So again, we want to mirror this feature along that initial plane that we extruded off of. So I'm going to go and create the mirror. I'm selecting a feature because the extrusion is a feature. I'm going to go into the timeline and find it, which just happens to be the latest one right here. I'm going to select a plane. It'll pop up on here. And I want to select the one that goes through the middle of this, right? So it's this one right here. It'll kind of give me a preview. You can see this green area is where it's going to apply that mirror feature. And then when I confirm it, it should cut it away. Yeah. So what happened is you're selecting that face instead of the feature itself. Because we're selecting that face, but it doesn't Yes. Yeah, that's right. Okay, we need more time on this. We're good. Okay, so you can see here, someone pointed out that it only made those details on that first one, right? And that was correct, right? I did it that way on purpose. And then I did that because I wanted to show that you can move things in the timeline. Similar to last week with that shell, if you create different features without making dependencies and you want to switch things later, you can do that. So in this case, we can move the pattern to happen after everything we just did. And because we edited everything on the original body, when I move the pattern to the front, it applies everything that we just did to all the rest of the pattern bodies, right? So yeah, that's what you want to do here. In a lot of cases, you may not have to do that because you may have had the foresight that you're going to create one and pattern the whole thing. But, you know, in some cases, you may have made something else beforehand. So this is another example just showing you how moving the timeline around can change your model. If that makes sense. Yeah. Is everyone good with this? Okay. The last thing on this is just adding a nice base to it, which is just a circle or a cylinder. So I'm going to make a sketch on this plane right here. I'm going to make a big circle, small one here. I'm not going to bother dimensioning this. But then I'm going to extrude it. For some reason, it will exclude that face that you create or that you made the sketch on for some reason. So you just have to click on both of them for it to be a nice full cylinder. Yeah. There we go. There's our engineering fountain. Everything good? Raise your hand if you need more time with this. Okay. I'll wait a little bit. Up or down. It's not. It's currently SolidWorks.
I'm gonna try and restart it because I selected, they said there's a newer version available, so I selected.
Oh, SP5.
Yeah,
I'm running SP3 right now, and it's fine.
yeah, I'm sure it is, I just figured I'd grab the new one if I could, but maybe that's causing problems, so. I don't.
I've installed Solid. Sometimes, like once you restart the computer before you install it, or it was running and all that.
Yeah.
It helps. Oh. Okay. Yeah. So when you get the sketch, you click on the line. Listen to the one. So you want to change that. Yeah, you just have to drag. So we have this
I did. Or I was supposed to do it on the, just so you face that out of the. Like, how do you find that? How do you? Is there a way to like edit the original sketch? This that we need some.
I mean, yeah, I mean, you can do that too.
Wait, do you have this one? Let's make it do. Hold on, it's like there's something else, but I need that.
Tracing the canvas, yeah. Most of the time when you're not. It's
Wait, I don't know. So was it?
but you know, for this demo.
Yeah.
Probably brown.
Okay. Yeah. Okay.
Yeah, and it's good.
On the budget and. Oh, is that what you meant to do? Okay. And. Steer the right direction.
This is we have Joe's. The one that's this. It's true. You can see it goes through the side. Yeah. So this is good. Yeah, so I'm gonna do the. It's very complex. Something that's it, like, just
It's like those direct thing.
It's you can see. It's showing. We are going to apply that from.
But no, I think it's shaded.
If you want to perfect. It's not.
Oh, yeah.
So he didn't really. Or like.
Oh, no, we're just like, they're attachments.
Oh,
Oh, you can just type it.
and then I assume you just.
No, I swear he was a mission, because you told us it was like, let me follow that so much.
People do it, I'll get like 5 people.
Did you look like it's a reason for submitting?
Yeah, I was like, wait, I don't think the first one. Yeah, I don't know.
I did do attendance form twice last week, and I was like, I know I did it once, I should trust.
No, the issue is I have like a bunch of formulas that like take the Google Forms and then pump it into like a big master spreadsheet. So when you submit it twice, it'll error out in the spreadsheet in the same, you'll have an error because it'll duplicate by the score. So then I have to like, so then I go back and I have to like manually delete like the one that's. It'll be, the worst one is the quiz next week.
No.
But the quiz, okay, The quiz is infinite attempts, right? So don't worry about failing because I didn't tell you what the right answer is. But people will submit it like 5 times because they click on the top one. And I'm reading this.
We just put the quiz all together.
Ooh, I should just give them no assignments. Yes. Yeah. The quiz next week is gonna be about 3D printing stuff. So sneak preview. But yeah, everyone good on this assignment? Yes? All right, sweet. All right, so now that you have a pretty good grasp of, creating individual models, you'll probably, or you probably have come to realize that most things that you make don't just have one thing, right? Laptops and, cars and stuff like that have thousands and thousands of parts. And typically, it's a good idea to test fit them before you make them. So one of the nice things about CAD is you can do that with virtual assemblies, right? So today we're going to be doing some Lego building, but in CAD. So here is kind of the goal of what we're going to make today. And then, yeah. Also, your homework assignment this week revolves around assemblies. So you're going to get really good at this. Oh yeah, here it is. Wait, why isn't the text there? Or the text is behind the image. Okay, I'll fix that. Anyways, yeah, this is a sneak preview for your homework if you haven't already opened the slides. Anyways, you just want to download this zip file and then extract it. If you're uploading it and you're wondering why it's not working, it's probably because you didn't extract it. Okay. So in Fusion, now that I've extracted it, I'm going to open up the data panel and I'm going to upload all the parts. So typically, I like to put it in its own folder so it doesn't get all mixed in with everything else. So I'm just going to upload it. Open the extracted folder. Select all the files. And then upload. And it's going to take a little bit. There's like a array of 9 squares up in the top left. You click what? Well, I just found a place where I wanted to put it, and I made a folder, and then I just hit upload. Okay, so this looks good. All right, who needs more time with this? Okay, sweet. So now that we have all these parts here, I'm going to create a new design. In this case, I'm going to create an assembly instead of a part design. This is actually a new pop-up. If you used to use Fusion, they used to not have this. And so I don't really know what the big difference is. So I guess we're going to kind of find out. But before, they were all kind of the same. So I don't know if the assembly tool is a little bit different. It looks the same to me, but anyways. Okay, so now we have this, workspace. The first thing I'm going to do is save the file. I don't know if this is the case now, but back then you used to have to save the assembly file before you inserted parts. So I'm just going to do that. So I've saved it. And then I'm going to start importing some parts. So when I create an assembly, I typically try to go off of, or I like to insert a part that I kind of see as a foundation to everything else. So, you know, if you're putting a car together, you're not going to start by grabbing a wheel and bolting it to other parts and put the car together. You want to start with the frame and then bolt stuff to that, right? So the same is kind of true for assemblies. In this case, I kind of think that the 2x6 plate that spans the whole car is kind of the frame in my mind. So I'm going to use that. So with the data panel, you can drag and drop, or you should be able to right click and then do insert into current design. You can see it places that piece in your design environment. In this case, you know, I think the orientation is fine. You can see here on the view cube, there's like that top plane that's over there. So, you know, I think this orientation looks good to me. I'm not really going to spend much time moving the first piece around, so I'm just going to press OK. One thing to note about the initial piece you place, Fusion will automatically lock it in place. So it's kind of like creating a fixed constraint, but for, you know, this part in 3D space. So you can see here, if you hover over the part in the top left, there's a little anchor icon next to the model name. So it's called it being grounded. So the first part is always grounded, just so when you create like joints and other relations to it, it doesn't fly around the screen. But if you do end up deleting the first part and you insert a new part, it probably won't be grounded. So like if I'm like, oh, I didn't really like this piece and I want to delete it, and I have nothing, and I insert a new part, in this case, the same exact part. Oh, it does. Okay, it used to not do that. That's kind of nice. But yeah, the first part's always grounded. Everything else is usually free. So we have this first piece. You know, we don't really need to do anything with it because it's just there. But now we can start adding more stuff. So what I'm going to add next is kind of the little axle pieces. So there's this wheel piece right here. I'm going to insert it. You can see it's kind of phasing through the other parts. They kind of do that. But what I'm going to do is I'm going to move it away. For me, I found it to be easiest to move the part to a place that's close to where I want it to be, but again, not exactly where I want it to be. Similar to, you know, making your sketches not exactly where you want them to be before you apply constraints. This is kind of the same before you apply, you know, joints or any other like relations. So in this case, you know, it's close, but obviously I want these two pieces to touch each other. So I have that. But now I want to make these connect with each other. So to do that, I'm going to create a constraint, this constrained components feature. If you used Fusion in the past and it's been a while, this is a new thing. You used to only make joints and stuff like that, but now they kind of have this constrained component feature that I think is a little bit better. The joint feature usually requires you to select edges and stuff like that. And in my opinion, it's not great to select edges when you're CADing, when you're making assemblies, because those edges typically change, especially when you're finishing a part and you want to make it nice and pretty. You're going to start throwing like fillets and chamfers everywhere, and then you're going to delete that edge. And when you have a joint in relation to that edge and you delete it, then your assembly kind of breaks. So when you're creating relations or constraints, I highly recommend you use faces and stuff like that instead of edges, because those faces typically don't go away unless you make a major change. And if you make a major change, you're probably changing the assembly. So yeah. So for this, you can start selecting some relations. So to me, I think like having these be concentric with each other is like a good relation to have. You'll kind of notice that in a lot of situations, you're going to be making 3 different constraints to fully constrain something in space, right? Like 3 degrees of freedom kind of require 3 constraints, except for axles and stuff. Usually it's just like 1 or 2, but it's because they spin. Anyways, I'm going to click on one face and then another one. This looks good. It didn't really move much because it's already concentric, so that looks fine. The cool thing is that I can add constraints inside the constraint tool, so I can make more than one at the same time, similar to making different fillets in the same operation. So I think it's useful because it kind of cleans up the timeline, because I can fully constrain one piece with one like quote unquote operation. So I'm going to add another one with that plus. It's going to ask me to select another face. I'm just going to select these 2. So now it's constrained in these 2 directions. So this can't spin anymore. But then the last one, I want these faces to touch. So I'm going to click this bottom one. I want it to touch this one. When I do that, you can see the piece flies into place where I want it to go. So this looks good. I'm going to confirm this. You can also see here that you can change some of these offsets. In this case, we want 0 offset because they're all kind of where we want to be. But if that's a thing, if you want that, you can change that. The other thing is having the flipped or non-flipped constraint. Sometimes you'll click on the wrong face, or it will assume the wrong way when you constrain something. I guess I can do it wrong real quick. It's kind of like the vertical and horizontal constraint thing, where Fusion will assume something that you didn't want. So, let's say we have this piece here, and then, I constrain it, or I want to constrain it. So I'm going to do this face and this face. So that's right. Looks good. Oops. But not configuration. Let's say I place this part. I mean, it's kind of symmetrical, so it doesn't really matter in this case. But let's say I really wanted this face to be coincident with this face on this side, and then this axle sticking out on on the left side here should be on the right. So let's say we want it to be in the other direction, and I'm like, okay, I want this one to interface with this one, and then you see it snaps to the wrong way. I'm like, I don't like that. You can flip it, and then it'll spin it around to be in the correct orientation, right? So, if you accidentally place the part wrong initially, then that can be useful. gonna do this. Looks good. But yeah. The other cool thing about assemblies is that you can nest assemblies, right? You can have assemblies inside assemblies. That's what people typically call sub-assemblies. So, you know, let's say you're designing a car, you're not going to have the whole car in one assembly by itself, especially if you're working with a team. Maybe some person's working on the suspension, right? They'll make an assembly of the suspension and then they'll send it to you and you just put the whole thing in. And it's especially nice when you have duplicates of the same assembly. In this case, right, there's 4 wheels and tires. So we can create a sub-assembly that has both of them in it. So we don't need to make a bunch of extra constraints. We can just do it once and then place it where we need it to be. So, oops. I'm going to create a new assembly. I'm going to insert that wheel. Looks good. Insert the tire. Again, when it gets placed, you know, it's placed in the right spot, but I like moving it away a little bit just to confirm I did it correctly. So I'm going to add some constraints. So for round things, I like to select those faces, and then I'll constrain these 2 faces with each other. Okay. Oh, this is cool. This is new. I'm learning stuff. So, oh, nice. Okay, this is actually new since the last time I used assemblies. So this is actually useful in this scenario. So I'm gonna delete this. But if you look really carefully for like this part, you can see that the tire is slightly more narrow than the wheel itself. So instead of creating that relation here, like face to face, you can create a centering one instead. Again, you could like measure this face and then change that offset, but it's nice that they have this centering feature now. Okay, so I'm gonna make them concentric, and then I'm gonna use the centering feature. So you can see it allows us to select 2 faces and 2 other faces, or I guess this one would be a center plane, which is kind of cool. We don't really have a center plane, so I'm going to select these 2 faces and then these 2 faces. So that looks good. I think it deleted the original concentric one, so if I apply that, then this tire here is centered on the wheel, which is pretty cool. We love it when Fusion adds new features. Okay, so I'm going to name it as a subassembly, make sure it's saved, and then if I go back into the original assembly, we can find that subassembly here and insert it into our assembly here. So to constrain it, I'm going to click this face. I'm going to make sure I clicked one of these round faces, make it concentric. And then I'm going to make sure the wheel is flush with this. There we go. Looks good. But yeah, I'll kind of give everyone some time to do this. Sometimes it can be a little time consuming. I think the assembly tools have gotten a lot better since I first started teaching this class. So hopefully it takes a little bit less time for you. But yeah, I'm gonna get really good at this because so this is what I was kind of because like these but it's typically like yeah, but you only that's only one of and then like it'll only work for this one. I usually it like it may not look right until it's like it's okay. I'm assuming if you were to it hides. So it's like it's on shuffles. So it's just axle and it's already for the last one.
Is it supposed to be super beautiful? So I would try. Yes. I'm not sure. Okay. And I'll do this on the. Oh. I haven't finished this one. I think I already see this. So I didn't see that. So. This is the. This is.
Yeah. That's.
Yes. This is, oh, this is.
But if you look at it, if you look really closely, or
We got this is this is.
this system. Technically, it's not. But I'm not sure. You could, you are right.
So like what you were saying, which is like it works. You can see. You can also. Stuff is awesome. But if we don't want to do that, these files are changing, but it's the this is like here and like the change order of this. To migrate to how this see edit the offset. So basically switch to and faces and
Okay, sure.
and we'll say this. What is this? Is this?
I guess. Or maybe at least.
But I'd say most. I just decided that's.
So I like, so like, we just like.
How's it going? Sure. And also- Yeah, so the preview will like, but it's a sub-assembly thing when you confirm it. So, where this one? I'm just doing this. It's not this one. These are. I guess what we could do is we can make a sub-assembly. This one. That's awesome. Just oh, I'm just waiting. This looks, that looks good. Okay.
I'm sorry, I'll do this. Oh.
This actually looks fine. And I'll show you. So you did click on the right basis. And you can see how it's not right. So similar to that aspect. Let's see. Oh, it's because we didn't.
I do that on my guide too.
No, it's okay. It's not nice. Oh, it's happening.
I did this circle and the circle and I'm gonna do this curve.
Yeah. So ridges, this maybe selecting edges.
Yeah, I'm gonna do
Or we can just click on this.
because I think it was trying to each other. So you just kind of work something. I honestly don't know. But I just initially you know, things that
Oh, yeah, I don't know. But it would be like.
so you say that or the file is
These either.
yeah, Fusion's really really
Okay. Is these edits good? That's what I'm doing. Their edits are possibly disease. But clearly not.
sometimes
I just want to know anything else.
so it's one way. So I think I know why.
We save my, or whatever is there.
Okay, so I think there was something.
It is.
Ah,
I know.
dude, it's like send it on the version.
Would you like to sit down too?
Dude, why is this pivot point like so far? Alright, so my assumption for constraint for some reason.
And I created that constraint by choosing instead of keys.
Let's just say like each circle has like its preferred range. Let's say we go this way. When you like click the constraint, like try to do that, and the arrows are facing the right way, and it's like, oh, you can't do that.
Yeah.
Like this, like remember, which is the first time I had that concentric constraint. This relation is this set, even though all the constraints were technically but then when I deleted the concentric one, and then I flipped it, and then I deleted the concentric one, then also, I guess like this subsentence and I could other subsentence with this insert it.
Yes.
But we're already like halfway there. So
How much more is on this time?
it's not. The other thing is this is the worse. It isn't actually terrible.
It's here.
Um,
So I wouldn't say you haven't been bothering me that way.
just
Yeah, it's true.
that's fine.
Yeah, this-
The-
Well, it's like my husband's do that.
Yeah, but then you might run into the same. But it's good.
Wait, I'll speak on that one. Don't even
Oh, okay.
worry. That's fine. You recommend doing that. And then to the next one, unfortunately.
So I did like. You see,
No. Do we hide that video?
so you use this first. Sorry.
Okay, this one.
No, this was. Because you made it consensual. This.
This was the second function, right? That, and then we chose this one.
Yeah, so. This first one basically.
Mhm.
Sure, this is correct.
Okay. Thank you.
That's
That's a lot for words.
I will say, like, even though Fusion assemblies have gotten better, have programs that including NS. Personally, my favorite is solvers. So, like sketches and slides. That was good solvers. It's a lot.
You teach this class, though. Like,
I mean, I do, but the reason why it's Fusion is because a lot of other milestone classes are Fusion, and also SolidWorks and a lot of the CAD programs. There's some
yes.
class
You can just hide it.
so class, but they have to get it.
If you add it somewhere else.
But you might be moving towards self-systems. That's sponsored by them. Yeah, or like the parent company. The other class. Or do you have the constraints? Or do you see us?
Yeah, that's what you understand.
So
You just put your mouth on it. This right now. I was like, yeah. Oh, yeah. Yes.
This is a lot.
It should be like. I guess I'm good with the outside.
It also. One, but it's fully constrained, it's like in the right spot. Yeah. This, so it's about here. I would prove. Let's see the first one. Second one. So these two, and now, see, one little bit about them. Or,
Do you want to consume? I know that's so. Oh. Yes.
Basically,
Yeah, so
you got constraint. Yeah. You click on like this face. And this is a so if you want to save some time, you can make a new assembly. Just use this to and yeah. That looks good. Oh, also make sure you apply appearances to the like,
This is it. Wait. So, it's started like. Maybe I don't need that. This one. No, I don't want this to be the same.
I mean, I taught you the skill to finish it. I did not.
Is this really this all the time?
And then just how does the 2x4 going across?
Okay, so I bet we want some other.
Well, you don't have appearances, so.
If we hire the humans. It's okay.
Might be- might be- might be- I mean, like, I mean, to be honest, even if you submitted that, it's just awesome. Pass the class. Well, I have exams this week, but I don't have exams next week, so I will try to do.
The way you're so annoying.
I can show you the stats from last. Past.
I'm still having a problem with once I drag it some way to find this. Try to just frustrate stuff. Still, what they do is a constraint this part, so the classes just.
Well, it's kind of so that's how it was. Roughly this, probably in some of that.
So, here. So. Right now it's constrained to be considered. We can, doesn't work, and then maybe look at it perfectly. So, I'm gonna do okay. No.
Maybe they can stream it out, so just something.
Yeah.
So about the different products, so it's not-
So actually, I would see.
It should. Oh. Oh, okay. So you have two files. You have Lego card assembly and Lego card assembly. Brackets. Brackets.
Yeah, it's all been put into this.
You
This
can
is
just
like-
put the things on it. So, you have to change the refund on both pieces.
You try to delete this. But not like this. Yeah, so if you look here, this is an empty assembly. And because that was the first thing we inserted. But this is the thing that's grounded.
Oh,
But then you inserted this 2x6, when we did that, it's ungrounded, so it like still moves.
Oh.
It should. But this is confusing. Like these orange ingredients. So
And then I realized that we want this to like, yes, and then one is like, okay, because it's just only one, you're gonna have to do that. Okay, perfect. It's like, we're gonna do that.
so I grounded it and then I made it revert to its original position. So that's why. But you see this, it should be. These up to the correcting.
it's just like.
Sometimes you have to
It's okay.
you sometimes put comments like the program. These
I'll just read some things.
three views. I think it's getting upset because these people yeah, this one. You can see like you're kind of constrained with higher even though you created it. So and it's thrown out here because it's trying to do both of them at the same time. So this one yeah. So this thing would be like using sometimes if you like resolve something bad and it doesn't move anymore because the or it's grounded.
You know that, the gas tube still looks like it's missing that. Like, you don't know. I don't know. Because I'll be constrained with this. So I just.
But you have to save the file. Oh, it's some. Okay.
All right, does anyone have any closing questions about assemblies? I hope you're getting good experience on this, because if you didn't hear before, your homework assignment is to create your own Lego assembly. So basically, the requirement is that you use 25 Lego bricks. So yeah, you're gonna get pretty good at this. I know it's annoying now, but just know that like assemblies are another pretty important thing. Like I have assemblies with like hundreds of components in them. So when you start making more complex things, you're gonna be doing this a lot. One thing to note is you don't need to use the Lego bricks that I gave you. You can download your own from ones off the internet. So I'll send some resources. I'm going to show you some now as well. And I'm also just going to go over online repositories in general because they're kind of useful. I know we're going over time, but I hope you bear with me for a second. But yeah, obviously you can use these bricks if you want. But if you wanted to find more stuff, you can go on websites like GrabCAD, or a bunch of other online repositories. I personally use GrabCAD a good amount, to the point where it auto sends me to an old search that I had. But GrabCAD library is a pretty cool place because all these models are free. So, you know, anything on here is something you can download and open, and you can use them. So, you know, people put a bunch of random stuff on here. You know, they do car models and all that stuff. But, you know, sometimes you can find what you're looking for on here. So, like if I look up Lego, I'm sure there's something there. You know, some of them are not related, some are related, but there's a bunch of stuff on here that you can use. And one of the reasons I'm showing you this is just hoping that you use these outside of just this assignment, just for stuff in general. Because oftentimes there's going to be some project that you're working on and you're like, man, I have this, you know, power supply or something, you know, it's this brand, and I don't want to model it, but I want to put it in a design of mine. Maybe someone else did it, right? So maybe like if I could spell, that would probably help. But like a Meanwell power supply is a pretty like standard power supply. You can see a bunch of people have modeled a bunch of different ones. So if you're making something and there's some kind of standard component, there's a high likelihood that someone's already done it or someone's already modeled it for you. So something or referencing these can often be a very good time saver. But also keep in mind, sometimes people model things and they don't model them super well, and like the holes aren't in the right spot. So, you know, keep that in mind because a lot of these are made by other people and sometimes people make mistakes. But it's a great resource. Another nice resource, which I guess is kind of unrelated to the homework, but might be useful for you in general, is McMaster Car. So if you're unaware, McMaster is basically like a giant online hardware store, and you can basically buy anything, including stop signs, which is kind of funny. You can also buy candy. But the other thing that's nice about them, besides Swedish Fish, is the fact that you can download standard hardware, because you know you don't want to be spending hours modeling a bolt or something when someone's done it already. So, you know, for example, you know, let's say I need an M8 bolt that's like 65 millimeters long. They have it. you can click on these, and then when you look at it, you can see you can download them in many different file types. Typically, it's pretty nice if you just use the step file. Steps are pretty nice. They're not like STLs, so they retain their curves compared to STLs. We'll talk about that next week, but step is a pretty nice file format. Most CAD programs can read it, so it's a pretty good cross-compatible file format. But yeah, it's pretty nice. I recommend you use these if you're ever modeling something that requires hardware. But yeah, also in like past internships, a lot of companies like to buy from McMaster because their shipping is insanely fast, even though they're kind of expensive. But you know, I think at some point I modeled like a mount for a tank. There was like a tank that not like shoot people, kill people tank, but like fluid reservoir tank, right? They wanted to hold some oil, and they had like a big container, and you could just download it, and then they wanted it to have like a custom mount for it to be mounted on like a railing or something, right? So pulling all like the dimensions off a step file and inserting it into a subassembly is really useful, because you can make sure it fits before you buy it or something. But yeah, I realize I'm over time, so if you have to leave, that is perfectly fine. But yeah, thank you again. Good luck on your exams. Yeah, I have one tomorrow, so I'm gonna be dead. But yeah,